I am Erin McDermott, your host, and we are here with a very special guest, Julius Muschaweck. He is the other Illuminations guy on Engineer that you can book time with, but we've put him into an even smaller niche as being the LED Whisperer and Colorimetry Pro.
Freelance and just doing my own thing is my favorite mode of operation, and then I'm free to choose. To work on the projects which I like, and of course to work with the people who are responsible for that and helping that. So that's it. But to be in a structure that just doesn't let me do the things I would like to do is not so good for me. So I am a physicist, yeah. I'm a physicist, and I think a good physicist should be through his whole life just something like a curious kid. Always curious, always eager to learn new things, and always, mentally ready to be truly and fundamentally surprised. And just taking nothing for granted. Yeah? And and I wanted to learn things and understand things on a deep level. So that's why I studied physics. I then found out that I don't necessarily learn all of that at university. And I was lucky to find that there was a professor in an institute that was working on solar energy at the time. And so I got there and got involved with solar. That was great. And then I did my thesis for some solar collector testing that was solar thermal, that had just little to do with optics at that point. And then that was bad times in Germany, bad times of physicists. It was 1990, the fall of the Iron Curtain and the unification of Germany. And one of the things they did is they dismantled the National Academy of Sciences in East Germany. And all of a sudden we had 20,000 unemployed physicists on the market. But my major thing was to do energy concepts for those buildings that we made. And we built them to much higher energy standards than were usual in the early 1990s. So that was great. But there I found out that at my heart, I'm not a real estate developer. I'm just a curious kid. And I wanted to go back to science. And I had a chance to go back to that same, physics department and the associated semi-private, semi-public research institution. And there I got into touch with optics, because the idea was to make high-temperature solar collectors that would just rest on the roof with no moving parts and create heat at 50% efficiency at 180 degrees C, 350 Fahrenheit.
Wow.
And a flat black plate just won't be sufficient. So we needed vacuum tubes and black absorbers with selective coatings and some mirror reflective troughs around them to collect and concentrate the sunlight. And that was interesting, and I thought it would help. And I thought, the optics part would be easy, just bend a little reflector and do some pocket calculator things. Okay. That was 25 years ago, and I still learn new things about this deep, beautiful topic of light and thermodynamics every day. It is just so fascinating. Yeah?
Yes.
And this is how
solve the problem though with the.
Oh yeah. We built this world record collector. Okay. And we built the first version of it here in Munich. And then I reported that in a conference, and Roland Winston became aware of me. And for the guys who don't know Roland Winston, maybe you heard the buzzword non-imaging optics somewhere. Mm-hmm. Roland is sort of the founder of that field, because he's a particle physicist, and he needed non-imaging optics to concentrate the faint light from Cherenkov radiation onto his photomultipliers. And finding that there was no established theory out there, he just did what good physicists do. He did it himself and reinvented. Of course, he reinvented many wheels, but he was the guy who actually made non-imaging optics a field in optics. Role model for that expert career path. Huh? So again, I was there at the right time by sheer luck, and got promoted to be like the global coordinator for optics in Osram. So I had no budget and no direct reports, but I was still responsible for making optics work on Osram for Osram worldwide.
But you need a problem. The problem is
You need a problem, you need critical mass, but you need the ability for people to speak freely. And that's what makes it so difficult out there. Right now, the world of illumination optical engineers, we estimate that it's maybe roughly 20,000. So they thought, okay, so let's diversify, and then they found that in the medical market, surgery microscopes, 3D surgery microscopes, which surgeons use to make really tricky operations on tiny things, like replacing the bones in your middle ear.
Wow.
Yeah.
What makes it 3D? Are there two different cameras?
There are two cameras, and so the standard way of doing it is to have a microscope, like a stereo microscope, but it's really stereo. It's not like a microscope which would split the 2D image into two pairs. It would be really like two pairs which come out in an angle. And that really makes things 3D, and they stand out, and you can see what you're doing in 3D with the magnification of maybe something like 4D, where you can see the details that you cannot see with the naked eye or with a loupe, but still not too much, so you can have this feedback. Then you see your hand moving without the instrument totally leaving the image because of magnification too high. So this is this intermediate thing, and Ari found that nobody is doing it fully digital. So they created this first fully digital stereo surgery microscope. Probably a very good idea to have a very good color rendering light source in there, just like you would do for general illumination, because then it just looks true.
And you use the same CRI color rendering index, because I know that there's multiple ones that they're playing with now. But...
No, and you shouldn't do that for a fully digital camera, because it is not the human eye which sees the light. It's the camera which sees the light, and the camera has a different sensitivity. And on top of that, you have, it is actually a little, computation intensive, and it needs to be done properly. But without too much of a delay, you can do quite complex computations on those images before you present them to the surgeon in the monitor, in the 3D monitor. And that is something that you can use. You can make colors which actually look not too good for the human eye, but which make the different types of tissues stand out in a way that you cannot possibly have with just standard illumination, because of the possibility to illuminate the tissue in a way. What I'm doing, I'm helping to bring people light where they need it and how they need it. That's basically what I'm doing. So people want to illuminate something for whatever reason, and typically just hanging a light bulb in a room is not going to be good enough. And so we need to do some more, and that more might be to put some optics in front of the light source and choosing the right light source in the first place, and then driving the light source in the right way, which is amazingly tricky when it comes to LEDs. And I know a few things about that because of, like 25 years of experience in that field. And so that's what I'm doing. I'm helping people to bring light where they need it and how they need it. And what I found again and again throughout my career in LED systems is that everything depends on everything. So I do this luminaire, okay, and it's like the lamp that goes into a surgery microscope. And then the question is, how much is the optic cost, and how efficient does it have to be? And maybe I can achieve the brightness level that's necessary down there with optics that's actually not too effective, not too efficient. Okay, and then it's cheap and it works well, except that if I would make it for a little more dollars, like 20% more efficient, then all of a sudden I don't need that much power in the LED, because that's then sufficient to reach the illuminance level. And that lack of heat which I have to generate up there may make the difference between passive and active cooling. And by doing a little more on the LED side, I can get rid of active cooling. I don't need a fan, which is probably cheaper, but it's also much more reliable if I don't need a fan.
If you would like guidance from Julius, you can directly book an appointment with him on oddengineer.com and get all your questions answered on things like colorimetry, LEDs, illumination, or whatever else about his background that interests you. And as always, for more details and links, you can check out the full article on SolidSmack.com. Thanks for watching.